So at this point, you've gone back and rewatched your video and or worked on your apps. And what you'll notice is that there's some really important things we need to practice. One of which is, how did life evolve early on? So we're going to take a few notes, and then you're going to finish filling in the rest of this assignment. Remember, evolution is going to be when we see, please write this with me, change over generations. And early life, remember, was early Earth. So there were things like no oxygen gas. We're talking billions of years ago. We can test fossils to see how old they are, and we know that billions of years ago, early Earth was very different from Earth today. And so on early Earth, it's believed that the very first cell might have formed. And so we do want to add in that the first cell might have formed through finish that word, what? How did that first cell form? And so the characteristics of that first form, we have written here P and H. The characteristics of that first cell, the P is that it is prokaryotic. They are simple cells, no nucleus. Ana, because they are anaerobic. They didn't use oxygen because there was no oxygen. And H, because they were heterotrophic. They had to consume food. Now remember, if carbs and lipids are being formed by the environment, then there's lots of food around for that cell to consume. And so what we believe would have happened is we believe, now look, I just gave you the answers to these. Why is it prokaryotic? Why is it anaerobic? And why is it heterotrophic? So think about why it had to be prokaryotic, why it had to be anaerobic, why it had to be heterotrophic. You can look back in your notes as well. So let's go on. Here's our first cell, and then what we're going to see is that over generations. So we're going to draw a little line, and we're going to label it many generations, meaning we've had lots of reproduction. And over many generations, we see mutations, mutate. And so as those cells reproduce, some of them will be pretty similar. Some of them will still be prokaryotic, anaerobic, and heterotrophic. But some of them might have mutated, and those are still prokaryotic, so a P. They're still anaerobic, but we can write that they're photosynthetic. And remember, photosynthetic means that you make your own food. So these organisms make their own food, and as a result, they actually release oxygen. And so these autotrophs, these photosynthetic organisms, autotroph means the same as performing photosynthesis. These photosynthetic organisms actually produce oxygen gas as waste. So because they have the ability to make their own food, they also release oxygen gas. Now, if these are also going to reproduce, remember many times, we'll still have some that are like the original P and H. We'll still have some that are P and a photo. But now, because there's oxygen, we're going to have a form of this one that's not ana. This one is going to be prokaryotic, aerobic, notice A-E-R, aerobic, and heterotroph. This one you should be able to fill in because it's still prokaryotic, but now it can use oxygen, and it still makes on food. And so what you need to see is the trend. First, our cells started off very simple because of how early Earth was. And then as they reproduced, we had mutations and got some new varieties. These can produce oxygen. Those reproduced, and we have new varieties because now there is oxygen. And then as these reproduce, this is where we see the endosymbiont theory, that some of them started living together. And so if you will make sure that you go back in your notes to complete this box, then that's going to help you study the evolution of early life. And when you're completed with this assignment, then you're going to be taking your CYK quiz. So you might want to study your timeline because you'll get to use your timeline on your CYK quiz.